Last presentation of the day. Hopefully you're still all awake. Going to talk to you about some collaborative robotics and basically how to implement them, what some strategies are, where they're good, where they're bad, and just the general idea of collaborative robots. Collaborative robots, what is the market perception? It's a new type of robot, easy to use, easy to redeploy, no fencing required, and low cost. And then obviously safe. What is collaborative? The ISO 10218, there are 4 different types of collaborative operations. First one is safety rated monitor stops. That's basically no robot motion when operator is in a collaborative space. This is basically used, we can use it for machine tending. When an operator brings a part to the robot will go pick up the part, and when it goes pick up that part, if the person is still in the area where it's guarded by safety or a safety mat, the robot will not move into that area unless he's gone. So once the operator moves away, the robot will go pick up the part and take it to the machining process to get all the operations done on it. Second one is hand guiding, robot motion only through direct input of the operator. This is done by just moving the robot around by your hand. Sometimes there's a joystick involved. Third one is speed and separation monitoring. Robot motion is only when separation distance, a minimum separation distance is there. So this is done by scanners by using safety softwares or dual check safety. You'll see examples of this, of the video showing, coming up. But basically as you get closer to the robot slows down to a collaborative mode.
Not as much.
All right. And then if you get too close to the robot will stop. So you can take a look at the tooling, take a look at the machine, see if everything's all right. Then start to move away. Then the robot will go back to a collaborative speed. And then if you move far enough away, it'll go back to its fast motion. So that way you can maintain a high rate of production at the same time as being collaborative. Then the last one is power and force limiting. This is basically what the collaborative idea of a robot is. Any type of movement into a human will stop the robot. The human will not get injured. And then the robot will obviously just restart again once the person has either hit a reset or just automatically restarts. This is a hand guiding, which can be done on our standard yellow robots. Obviously, there are some safety scanners around there, but this is basically a robot's picking up a heavy part, presents it to a station. Then our operator goes up and can use this device to maneuver the robot around to put it in whatever location possible to do some kind of ID of the part or just to check for any defects. But that movement right there is just done by the operator, and within that button you can also teach it. See, there's the area scanner on the bottom. But this gives more flexibility to standard robots where the collaborative idea actually brought to this industry. And then the next is just the hand guidance, which is basically what everyone has been brought up on. One thing too to notice is that once you're going to go through your risk assessments too, is though that there really are no sharp points on this robot, even on the tooling. Because that's one thing you have to look at through your risk assessment to make sure that if the robot runs into you, there's not going to be anything that can puncture or hurt you in any kind of way. But you can jog the robot around, teach it. There's teaching buttons on there, and then you can just walk away, run the program, and the robot's off, good to go. And she walks away and just goes back into automatic mode or whatever program she taught. Hand guidance. Some of our heavier collaborative robots are 35 kg, so we've seen some instances where people want to use them as lift assists. So basically picking up large items with that tooling you just saw on the yellow robot and then moving it to a certain part, and then once if you don't need it as a lift assist anymore, then a robot can go back into it. It's in automatic mode and do whatever functions are necessary. But obviously there's a lot of issues sometimes with lift assist. People really don't like them. Repetition tasks, but this is a good way of using a robot in the same time as a lift assist. This is the speed and separation monitoring, which I mentioned. Not that video's gonna. There we go. So right now you see a green light at the bottom. And we actually have this demo set up at our facility up in northwest Houston area. But once the green light's good, it's moving in its fast rate. Person is going to start walking up. The light will change to yellow. It's going to slow down to a collaborative speed, 250 millimeters per second or less than that. And then if he gets too close to it, it's going to stop. That's what I said. Basically, you can take a look at the part, or if he's just mistakenly walking through, it's not going to stop. It'll stop production, but the robot, once he moves away, will start running its normal production again. And obviously slow when he starts, but then as soon as he gets far enough away, then it'll go back to fast production speed. Obviously, there are safety scanners around that. Contact stop. Let's see, this is just going to run into them and stop. This is pretty much what all collaborative robots do nowadays. There's a reset button on the back of that, but as soon as it runs into him, it'll stop. Power and force limiting. This is one of the things where a collaborative robot brings a part to an operator. The operator can do some assembly on it while the robot's holding onto the part. So this way you don't need to buy expensive fixturing. If something changes, the robot can always maneuver around it or change to however it is, but that way you don't have to worry again about buying expensive fixturing or worry about different kind of parts that you're bringing into it. You see here, it's going to pick up that shaft, bring it over to the operator station, present it to the operator. And normally this would have to be probably brought over, depending on the size, by a crane or some kind of other heavy lift assist for that. But this way the robot just brings it over, presents it easy ergonomically to the person that's assembling it. And then it gets assembled and he takes away and does the same process again. It's been assembled and he picks it up and takes it away. Okay, what is the reality? A new type of robot? Yes. Robot design must inherently limit the force applied upon it when it hits somebody or runs into anybody. Easy to use, yes. New user interfaces and tutorials. Hand guiding makes it easy, so that way you have to run through a teach pendant, go to point. You can actually do it by just jogging it around and hitting your record button then. But then also it's not, because integrating other devices are the same. And then also still requires a risk assessment, which I'm going to keep on going over in this presentation just because of it's necessary for whatever task of whatever robot you apply, the risk assessment is there. Easy to redeploy, yes. Some models are light and easy to move around. But then again, if you do bring it to a different station, a new risk assessment has to be done. It just can't be moved and say, hey, the robot's safe. Low cost, yes. Smaller models can be the same price range as standard industrial robots. But no, risk assessments could require additional safety measures too that you didn't think about. Okay, yes, it has maybe a sharp knife or something that's really not collaborative, and then you're going to need more additional safety features for it. And then the larger models are going to be a premium over the standard industrial robots. Pros and cons. Traditional fence robot, pros, fast throughput, lower cost. Any kind of robot can be used. Cons, it's pretty much a larger footprint, no human interaction, and typically requires written and extensive procedures to enter the work cell. The fenceless system, pros, you're saving some space, faster cycle time instead of the normal speed of a collaborator where it's slow. Cons, robot must stop when somebody enters the operation area. The footprint could be a little bit larger due to the size of the scanners, cost of the safety devices that are on it, and safety distance calculations will be required. And then for the power and force, like the traditional collaborative robots, no fencing required, no safety, additional safety possibly. Robot stops when it hits an operator. But the cons are slower cycle time. If you really need high-speed output, then the collaborative way is not to go. Because obviously the faster a robot goes, the more it can hurt somebody. Extra design considerations need to be done. And then also a risk assessment is a lot more in-depth when you're using a collaborative robot because the standard safety structures aren't there. Safe, yes and no, when deployed properly with a risk assessment. No, the process may not be collaborative. Blades, clamps, even arc welding, high speeds. But eventually, the plant is always responsible for the safety and doing their own risk assessment. No fence required. Yes, again, I'm going to keep on harping on the risk assessment, but it has to be done with every kind of robot that you install. And then, once again, no, some robot speeds or processes might not be safe. If there's any kind of interaction where the robot has a device or tooling that's going to be close to somebody's head, that's going to take a lot more risk assessment time to get that process through. And again, the plant is responsible for all the safety. What are good applications? Low speed. Typically, the collaborative robots are the speed of a slow human. Obviously, applications that are within the payload and load capacity of the robot. A more portable solution is a great idea for collaborative because fencing is not required. Could not be required, I should say that. And it's maybe a seasonality, say you're doing certain items towards the end of the year that you don't do at the beginning of the year, so that way you can redeploy the robot to a different station. Applications that tend to be simple are great applications for collaborative robots. And then also when interaction with humans are there 8 hours a day, 24/7 or 7 days a week. What else? I mentioned collaboratives are generally slower. They might not impart higher assembly forces. So if you're putting force on the collaborative robots, obviously the robot is looking for force to stop. So if you're applying force to it, sometimes you need to turn off those safety functions. Like when you're grinding, if you're applying a certain amount of force, then you'll need to take that safety factor off because if a human walks in there, then if he gets that force applied to him, it could hurt him. Do you need collaborative? Like I said, is the operator always going to be in that work envelope 24/7? If not, if he's only going to be there for an hour a day, collaborative is not really a great idea for that application. Because obviously you can increase your throughput by having the robot move at a quicker speed. And then, like I said, do you need higher throughput? This is just some of our collaborative models right now. We do have the strongest collaborative robot on the market. That's a 35 kg robot, 1.8 meter reach. We have everything from that down, a 15, 14, 7, a 7, and a 4. 7 and 7 and a 4, sorry. Different speeds depending on the model. You can actually increase some of the speeds with safety scanners around them. These are speeds determined by us. The RAA really doesn't have a speed number out there just because it depends on how heavy the product is, size of the robot, things like that. This is our new model that's coming out in June. There's two models, a long arm and a standard arm, both 10 kg, a little bit of more reach in the long arm by 1.4 meters. Gripper connections, lead through teach. I've seen a video of actually someone teaching it by just moving it with his pinky. It's a lighter weight than our standard robots, 39 kg and then 19 kg with the controller. Speed is 1,000 millimeters per second. We will have some through-arm cabling for our I/O and vision or force. One thing with the FANUC robots, every robot comes with vision and force internally to the robot controller. It's not a third party. And then the I/O, but still the air will still have to be routed outside. There are no air lines currently right now going through it. The new tablet, it's icon driven, e-stop at the top, easy to program. This is actually kind of similar to the same way of our standard robots, which we did about 3 years ago. We came out with our new controller, call it our ease of use. It's intuitive, tells you next step. You don't have to sit there and scroll through menus to find out where you need to go. It'll tell you what to do. But this is just another version that it's going to be a little more easier to use, I should say. Just a summary, it's a new tool to help with labor shortages, allows possible easy entry into robotics for smaller companies, different solutions. Standard industrial robots can be used collaboratively too, which I mentioned, depending on the safety IO that you have set up or DCS. Like I said, the key thing is it's always going to require a risk assessment no matter what kind of robot you're using. And sometimes the collaborative robots are going to require more in-depth risk assessment to get the safety factor in place. Not a fit for all applications. As I mentioned, it's slower and it can impart higher forces on it. Automation, cooperation, and collaboration. 3 different areas that you can use FANUC robots for: standard, semi-collaborative, and actual collaborative market itself. That's it. Any questions?